Hey guys, good morning. Welcome to week two and all. Yeah, okay. Well, we're gonna give people a little bit of time to join us. Hey, today I'll be gone. Like I said, what is it? Let's say 8:45. Yeah, I'll probably take off around 8:45. Um, and we can do two things, right? I think I can either pause the recording when I go and then restart it when I come back. That's a possibility. Yeah, then I'll have to post two clips and all, it's pain. But let's leave that as a last resort. The other option is I think I should be able to hand over the host to one of you guys, right? It's the Zoom allows me to nominate one of you as a host. And then you can basically pause the recording and then restart it, and then it'll just be one clip. I think, I don't know, right? Or if you guys don't care, you can just record the whole thing, right? I think that'll work too. I'm right. It's just that I'm going to be off and you're going to be talking. And if you want to be talking off YouTube, you can pause the recording and talk and then re-record. Is that okay with you? Can one of you guys just, raise your hand and we can try around 8:30 or so to hand over the host thing to you, and you can hand it back to me, and then I'll give it back to you at 8:45. Yeah, this is that okay? Can one of you take over from? Wow, is this the brightest? The days are getting darker. All right. Okay. Well, and by the way, I think we have a couple of people from CS2B. Because in fact, what I did was, I don't know. There was a past student called Virginia Bowell that I mentioned in a class the thing is, I forgot whether I mentioned her to you or to the previous section, because it was in the context of VS Code and her having made a video of how to use VS Code and set up the IDE and all, right? So I brought her name, and strangely, out of the blue, she contacted me yesterday and said she's back at Foothill now to try things out, right? Something else, I think. So I mentioned to her, hey, your name came up in a lecture, so I said, yeah, you're welcome to come along to the lecture too, and the more the merrier. So I sent her the Zoom link, so she might even turn up today just to say hi to you guys. All right, so can one of you basically just volunteer to take over as the host of this meeting from, I don't know, 8:45 until I come back? And if I don't come back, yeah, hopefully I'll be back sooner than later. But if I get stuck or something unexpectedly, just carry on the meeting, right? Carry on playing, right, with the code, and it'll be captured on video. And then we can have, a follow-up class if you want, off schedule, or we can talk about it on Reddit, we can talk about it on Zoom, we can discuss it over email. A whole lot of interesting opportunities open up, right? But I'll get you started. Before I go, I'll get you started with an interesting project, right? And make sure that every single one of you who signed up, right, who's on screen, okay, even the guys who haven't got their cameras on, all right, you guys, yeah, okay. Madison has special permission. She doesn't have a camera, right? Francis, yes, there you go. Musa and Yasser, both of you got to switch your camera on. Jared, did you have your camera on before? Yeah, okay. All right, good. And Musa too. All right, and hopefully one of you will, take over for about a half hour, okay? And everyone who's in class today, it's 8:07. We got to give them 3 more minutes to sign up. I don't know. We got to tell people that class is actually going to start at 8 a.m. from tomorrow, right? From next class on, it's not going to be blabbering on until 8:10, and then we'll start at 8:10. It's getting to be a habit, so I think we should stop it before it gets out of hand. Or is nobody else signing up? All right. Anyway, so why is nobody okay with taking the screen from, you don't have to drive anything, right? So all you need to do is just be host. You don't have to say anything. Zoom, from the perspective of Zoom, you're the host, right? Which means that the meeting will continue even if I leave. That's the meaning. When you take over as host, I'm free to leave and the meeting will continue, right? If you're not the host, I leave, the meeting ends for everyone. That's all it means, right? So all you need to do is just hold the reins of the horse will drive, right? Itself. Just be the host. And so the meeting will continue and then I'll come and join you again as a student, as someone else who's got the link, and then you can pass the hostship. I don't know, what do you call it? Back to me whenever you feel like it.
I can be the host.
Yeah, Lei, or thank you, Lei. All right. So in fact, what we'll do is, since we got a couple of minutes left, why don't I make you the host right now? Tell me if it works, and then you can give it back to me. All right. So that's what we'll do when I disappear. Okay. All right. Because I got to figure out where the hell this thing happens. Where is window, Zoom, meeting, make someone host? Oh, maybe I need to click on you. Maybe I need to click on you to make you host. There you go. All right, make host. All right, make host. All right. So now, did you get a notification or something?
Yeah, I see it. It says you are the host now.
Great. Okay, so I'm gonna now take off from the meeting, right? I'm gonna hit the leave button. So I'm not going to be here. And by the way, right, at this time when I'm gone, you guys can talk. That's why I said, if you don't want this to be on YouTube, that's great. Go for it and pause the recording because I'm not going to be within earshot, right? So I'm not going to be able to hear what you're saying. So you can call out to me, right? You can't even email me. I'm not going to be checking email and all, right? So, but I'll be back. Right? I'll be back just half an hour. So you can't call out to me or anything during that time. And you can feel free to chat on your own, right? Or if Virginia is here, you can basically talk to her, right? About the experience with Tue and so on and so forth. All right, I'm going to leave the meeting now. Everybody okay with that? Yeah, I'll come back immediately in a couple of seconds, but I just want to see if this thing works.
Is anyone using Sea Lion for their IDE?
Using what?
Sea Lion, it's the JetBrains version of Visual Studio.
Oh, no, I haven't heard of that. I mean, I've heard of JetBrains, but yeah, I'm just using VS Code.
Okay, I might have to. I heard from a friend who writes code in C++ that you should use Sea Lion, but they don't have a community edition.
Oh.
Yeah, so that sucks.
Yeah, the only thing about VS Code is I still can't figure out how to get it to compile in the latest version of C++, which is kind of annoying. But besides that, it works nice.
Okay, I'll try that.
Yeah.
All right, so I'm back, and you can make me host again if you want. But if you can
automatically
just, I think what happened was that yeah, Josh, that's great. Yeah, it doesn't matter if you're late. I just yeah. As long as people are participative, that's fine. Okay. Hey, Lei, where'd you go? I can't see. Oh, there you are. Okay, you just shifted. You know what Zoom should do? When new people join the meeting, it should add them to the end without shuffling the positions of the people already in the meeting. Because when you fixate on a person at a certain XYZ coordinates, and then it changes, it's a really cognitive, it's jarring, right? Okay. All right. So what was I saying? Yeah, Lei. So the thing is, it stopped recording when I handed it over to you. So I don't think it's recording right now. It's probably, and because you're the host, it's not recording. No, what is it saying? Why is it saying it's recording?
I think when you came back into the Zoom, it automatically started recording.
Oh, I see, but it's a brand
you.
new recording.
Yeah.
Yeah, okay, all right. So this one started when I came back into the meeting.
Yeah, and you were automatically made host as well.
Oh, I was automatically made host.
Yeah, since you're the owner of this meeting, I think that's just what happens.
Oh, wow, I didn't know that. Thank you, Neil. Hey, Neil, your camera needs to be on, okay?
I was gonna email you, but I can't turn my camera on today. I'm actually at the library right now.
Yeah, don't worry, don't worry.
yeah,
Okay,
sorry.
that's fine. Yeah. You're vocal. That's enough actually, right? The only problem is with like Musa, who is neither vocally participative nor has his camera on, right? So I don't know if you're even here.
Sorry.
So all right, good, good. So it's 8:15. We've got a half hour to get started and get going. So I'd like a volunteer from you. And if you don't volunteer, I'm going to nominate not Hiram, okay? Because he had a chance last quarter. Everybody will get a chance. Hiram, you'll get another chance, right? You get many more chances, but I want to rotate. So anyone other than Hiram, take the screen, okay? It doesn't matter. All you need to do is just take the screen, but you need a browser at the very least. If you have Xcode or Visual Studio or something else, that's fine. It doesn't matter, right? I want every single one of you to be able to do this, right? Every single one of you. So everyone on screen anyway, right? At the end of today should have been able to do something. And then we're going to do this thing where everybody contributes to this one big thing, okay? So it's just an idea that I had. Okay, so someone take the screen and just an empty screen, a private browser, open up a private window in your browser, okay? And then we'll start coding right from there. I'll call out the very first skeleton of the program, and then we'll talk about how to take that and put it in your IDE, make it a CPP file and things like that, right? All of that is simple stuff, but we need to just get going and see something happen in front of our eyes, right? So that first thing to, all right. So who can take the screen?
I can do it today.
Great, Alexandria, go ahead. Take the screen.
Okay.
Although you're going to do it in a browser, right? Not in C Line.
Yeah, in Python.
Okay.
Do you see it?
So everybody can see Alexandra's screen, right?
Yeah.
Okay. All right. So only one person spoke up. All right, and maybe that was Neil. But
Yeah, I can
Yes.
as
You
well.
can see it.
Yep.
all right. Great. Thank you. Thank you. Let's just go. In fact, let's not go to a specific URL. Now is this Chrome?
Yeah.
Okay. So just type online C++ compiler right there. Okay. And there you go. Compiler. All right. Right there. What is it? Which one is it? Online GDB. All right. Okay. All right. So this
Online GDB.
yeah, we've used it a couple of times last quarter. Someone brought it up. Who was it? Yeah, someone was Chris maybe. Yeah, very convenient. And there's a whole bunch of editors like this, right? This and Tutorials Point and cpp.sh. So you can pick any of those. Now, here's the thing with these online editors, right? So whatever you type here is being saved in a document somewhere. And they also give you all kinds of features, like you can group documents together, you can even debug things. So anything you can do on your native IDE on your computer, you can also, most of the things, right? You can do on an online IDE, including versioning and all these things. So why do people use, something installed on your Mac, like a C Line or VS Code or Xcode? Why do people use that? Why don't people use something like this all the time? Because you can do some pretty large projects. No, I'm not saying huge ones, right? But you can do some pretty large projects here. So why do we think that people use these online, hard disk IDEs at all? Why not always use something online like this?
But you can do like unit testing is easy and like.
You can do all that too. Yeah, there are online IDEs that just hang on one sec, okay? 8:17. All right, let me set a timer reminder for me. Alexa, remind me to stop the meeting at 8:45.
Okay.
8:45 a.m.
Okay, I'll remind you at 8:45 a.m.
Okay, all right, good. Now I don't have to remember. Good. So what was I saying? Alexa, stop. All right. So that's all right. Right. So why do people use something on, you can do profiling, you can do a whole lot of things online. So the problem really is speed, okay? Speed and latency and the dependency on the internet, right? You have to be connected to the internet and so on. But most of the time, fortunately, because of us, right? So we're so lucky now, right? We can do all our work on Xcode or VS Code or something local. But if you have a library or something, you don't have to be dependent on one or the other, right? So you can switch to an online, except your files will be in one place, right? But if it's on Git or some other place, you can just synchronize everything and everything works out. So what I'm trying to say here is that we'll use this initially, but you will see a seamless transition, right? At some point, your code will become so not trivial, right? So you'll have 3 or 4 files to manage. They're online, you got to log in, and you'll see it's actually much simpler to just have it on your hard disk, okay? Because sometimes you actually need access to the file, right? And instead of copying and pasting into a document, it's easier to actually have the document and edit it. Did everything so far make sense? We can actually start editing this? Okay, great. Thank you so much. And by the way, anytime I launch into a huge, thing about something very simple, and everybody understands very clearly, you can just feel free to raise your hand and say, hey, stop, right? Everybody's okay, can we move forward, okay? All right, great. So this is your shell of a C++ program. Now, what I'd like is for every single, now if you run it, it should basically say, change the hello world into something else, right? Change the hello world into something else, right? Because, actually, if you think about it, it is 99% of your first quest. This is basically 99% of your first quest, isn't it? Right? It's not 100%, right? So it's a little puzzle for you to find out why it's not 100%, but it's only 99%, right? You probably get only 0.9%, 9 points instead of 1 point for submitting that, right? So if you run it now, it says hello, hi again, right? So there you go. Now, that is basically a very, very simple program in which cout is an object, right? Which we'll get into all of the details later on. We'll get into all of the details later on. Now, in some programming languages, right? Alexandria, just go on to the next line, and hit 2 forward slashes, right? And then you say, in some programming languages, just type this, in some programming languages, the above statement would be stated like, right? And on the next line, another comment again. Yeah, that's called a comment. Anything after that, the compiler doesn't care. You can put anything you want there, okay? Right, and so you can say print, and then within quotes, you say hello, hi again, right? And within quotes, you say, and the whole thing is also within parentheses. But that's fine. I think in Python, you don't have parentheses. Yeah, that's fine. Let's say, no, you don't have, let's not do parentheses because I think more people are familiar with Python, yes? Right, than with other, like Java, right? Raise your hand if you're a Python versus Java. If you don't belong to either camp, that's fine. But I'm saying among the people who belong to one of those 2 camps, I think there's more Python than Java. So let's just use Python syntax where possible. I think it'll make more sense to everybody. All right, so so what that means is basically this is print. That is basically what that is, and the 2 less than signs is basically what is called an operator. In some, open another comment and say in some other languages you may have parentheses. Now you can say the same thing with parentheses, right? Yeah. Thanks. Yeah, maybe we should have just said 1 word. All right. So all right. So does that make sense? Right. So technically, you can also maybe in a fictional language it may be, right. So on the next line, you could say in a fictional language it may be I don't know, say something like say something very Shakespearean for print. I don't know. Spake or say or speak or just say speak for now. All right, speak, right? Speak, and then you can just say the whole thing within single quotes, right? Within single quotes, or you can even say, and between the 2, you can say you put an arrow sign, right? So maybe that is a syntax that you're going to define for your own language, right? It doesn't exist. but it's a very important point. I think is everybody okay with this so far? Maybe you're going to design a language in which you say that when you want to print something to the screen, this is how you say that. Yes or no? It's possible, right? This is your own language. You can do whatever you want. Yes. Okay. So likewise, C++ chose to do it this particular way. So are we all comfortable with this particular syntax for what is called an operator? So this thing, this the arrow thing that Alexandria just wrote on line 19, that arrow thing is what we would call an operator. An operator is something that, takes the operand and the argument and combines them together, right? So plus and 3 and 4, right? Operator and the operands. Everybody okay with that? Okay, just like that, Alexandria's got an operator, which the operator is the arrow sign, yeah, okay, and the operands to that operator are, something called speak and something called a string whose value is hello, hi again. Okay, so this operator gets given two things. It gets given a string and it gets given a thing called speak. That's how Alexandria has designed it. Right? So C++ said, okay, we're going to use something very similar, a similar kind of, freaky syntax that says, double less than, okay? And, all of this will make perfect sense in just a couple of weeks, right? Double less than, which means the double less than is our operator, okay? And when I see a statement like that, I'm basically going to call that operator, whatever program is attached to that operator, whatever code, right? So because your program is a whole thing, your code is some snippet of that, whatever sequence of instructions is attached to the operator, and give it two things, right? One of them is a string, right? And the other is going to be some object, which is probably a console, right? If it's not a console, maybe I'll give it a file stream, or you can give it anything. But that operator just needs two things. It needs a string and it needs something to put the string in. That's all, right? Cout is that other thing. Cout is a console output, right? Likewise, cin is console input, right? So cout is to the less than operator, the double less than operator, right? So some people call it the insertion operator, I think. I don't know, right? So that to that operator, right? That piece of logic, you're giving two things. One of them is what to put in where, right? So the container, which should take something, and the thing that should go in the container. You're giving those two things to the operator. Is everybody okay with this so far? Great. Okay, now let's try something slightly more fancy. Okay, so and now I want to try something more fancy on the next line. Say cout, and then we're now and put in a blank line before that, so that we're now in experimental territory, right? So okay, so now here is where we're going to, it's basically starting out, and then everybody's going to do their own thing, and they're going to call out code when I'm gone, and everybody's going to say, and there's going to be a comment, and then their version of the cout underneath, okay? And then we'll hopefully have lots and lots of different versions. Try it out, and some may work and some may not work, and we'll have a great deal of fun, okay? And figuring things out, okay? So in fact, let's put a comment right on top of that. There you go. And you can say Anand's a cout statement, right? So this is mine, and then a blank line after that, comment that says Alexandria cout statement, okay? And then she'll come up with something, right? And then hopefully each one of you is going to try out this thing on your own, in your own IDE, and then call out your code to Alexandria, and then she'll say, Jared's cout statement, okay? And so on and so forth. Everybody's going to get a chance, and everybody will get a line. Everything goes into this one program. Everybody okay with this, right? It's not all going to be the same, right? So try and do some variations, right? So here's my variation. Okay, cout double less than my and then within quotes you say my name is, all right, and then I want to put a new line character in there, a new line, an end of line statement, right? So I can, a new line is /n. Now there are many slash characters, which I will leave you the joy of going on the internet to find out what these escape characters are. They're called escape characters because they let you escape from the normal way of interpreting strings into a completely different way of interpreting strings, and then come back. Right, so you escape, use a temporary escape from reality, okay? So /n means it's not a real n, right? Don't interpret it like an n. Escape, because the slash tells you to escape, interpret that as a special n. A special n is a new line character. Okay, /n is new line. Okay, so every time you say /n, you actually get a new line. Now, right after the /n, say my name is yeah, okay, yeah, and you should say, and then within parentheses, you should say this should be on the next line, right? This should be on the next line, right? Yeah. I don't know if you should here, this should be, right? I don't know if this is, right? So when we run it is when we'll know. All right. So this should be on the next line, and then maybe we can even get more fancy, right? So you can say, and then on the next line, I put in a slash. Oh, here is another way of creating a new line. I'll show you this one also, right? After that, at the end of at the very end of the line, say double, double less than again, right? And then say ENDL, right? ENDL, right? That means end of line. It is the same as new line, except it does a few more things which we won't get into the details for, right? So you can Google and find out. It's all very simple, right? All right, on the next line, don't say semicolon, because semicolon is what ends the line. We're not going to end the line. I'm still continuing with my statement. On the next line, indent in to say that we're still part of the same operator. So double less than, right? One more, two, yeah, double less than, and say within quotes, say 2 + 3 equals equals, yeah. It's again, I'm putting a space before the equals also. Yeah. All right. Cool. All right. And then here, double less than again, right? And then within parentheses, say 2 + 3. Right? And then you say double less than end line, right? So this is what I've said. Now let's just compile we need a semicolon to end it. Now what I tend to do, and you don't have to do it this way, is when I have a sequence of couts like that, I usually put the semicolon on a line by itself, so that you'll find out, I don't know, maybe it's useful because then it lets you shuffle things around and play around with the order and things like that without having to worry about the semicolon getting in the way. So when you have to declare long vectors or strings or things like that, I usually put the semicolon on the next line. I think it's a holdover. I don't know, when did I start doing that? A long time. When I was a grad student, I was programming in a language called Prolog, right? I think the semicolon needed to go on the next line or something like that. I think I got in the habit and thought this was a nice pattern. All right. So if you do this, it's really cool, right? Because if you have different things, different lines speaking to the user, you can basically also visually put them in the program also on different lines. You don't have to see, what I've done there is really unsightly, right? And you should never do that in real life. What I've done there is I used an inline new line character. Does everybody understand what I mean by an inline new line character? Yeah, so inline new line character means if I simulate that in my head, I know what the output will be, right? Because I know it'll print that and then it'll go on to the next line and print that and so on. Now, I don't like that in programs. Although technically it is correct, the compiler will not complain. It is I think it is bad habit, not just to other programmers, to yourself later on, because the visual presentation of your program does not mirror what the user will see. And therefore, there's going to be this disconnect. When you write a program, as a product designer, I feel that we should always be in the shoes of the user as much as possible. We should connect to the user as much as possible, right? And try, I think, try to be, I don't know. If you see what the user sees, I think you can save yourself a lot of work. Because if you don't see what the user sees, then you may release a product and the user may see something different and they get back to you. And then you see what they see. And then you have a whole lot of things to fix up, right? And so I think it's easier on you, even practically, right? When we start coding and building things, to start looking at things. And also the other thing here is, so I would never use /n like that, right? And you should not. And you can actually make a comment right there. Yeah, and say that using an inline /n is a bad idea because it does not reflect what the user will see. Yes or no? Yeah, and the other thing that to keep in mind is that sometimes when we program, we like to take some shortcuts and do clever things in code, right? Clever. In fact, Jack Morgan, I think, a student from almost a year ago, right? He asked this question, right? So how clever can you be in coding, right? So the thing is, and the thing is, if you take a shortcut trying to be clever, and it is really a shortcut, but you need to be clever to understand it. Chances are that that cleverness and the shortcut only made sense to you in that particular time and space, right? 5 years down the line, you are reacting to different stimuli. You've forgotten a lot of things. That cleverness may not make any sense to you at that point, right? Or maybe it's cliched and people don't use it, or better ways have been discovered. So I think it's always, trying to be clever at the cost of readability is a huge cost. It's a huge cost. And also, clever, I don't know, whenever we have a choice between being clever and being beautiful, I think we should always just pick, being beautiful makes sense. It's clear, it's nice, right? We understand that. That's much better than being obtuse and clever and efficient, because, cleverness, I don't know, it's clever things are clever only a certain number of times, right? After that, it becomes, routine stuff, right? You teach that in elementary school even. But beautiful things are beautiful always. So that, if you see all the surviving artifacts, they survive not because of the cleverness, because cleverness keeps getting integrated, and then it becomes part of our, subconscious neurons, and, people become unable to see it, right? Or even it may not be, we may not understand it. So I think we can be as clever as we want, as long as we're not too clever for ourselves. All right, I think that's what I told Jack. So, all right, so is everybody clear with this? What time is it now, by the way? Oh, we got 10 more minutes. So we can do more things until I go. Alex, yeah, go on. People should try. Everybody should try different ways, and experiment too, right? And in fact, if you don't have to try it on your own, you can actually try it right here with Alexandria. Have Alexandria type it in, and I think that, and if it doesn't work, then you could all brainstorm together. And I will too, as long as I'm here. I will too. Why it doesn't work and what we can try, and we're going to try variations of that to see if it works. All those lots of interesting things, right? So here's the time when we start experimenting with code, and I think experimentation will really is really what will get us to the to appreciate nooks and crannies of C++. The real power.
I want to try something.
Yeah, go for it. Go for it. All right. So this one's Alex's, okay? And you guys other people should also be thinking of their own.
I'm just thinking of like Python and Java. I don't know if you can do this.
No, wait a sec. 2 + 3 equals. Oh, I see. You know what? It's very interesting. Let's try that. By the way, one sec. The output didn't look quite right. Hello, hi again. Oh, I see. You don't have a new line after that. Put a new line after the hello, hi again, right at the very top.
Up here.
Yeah. You need a double less than. No, you need a double less than.
Oh, right.
Yeah, or you can just put you can have an inline slashing character as long as it's the very last character of the line. So you can say, you can get rid of that, and yeah, that's fine. Because it's the very last thing, it is what the user sees also, right? So that's fine. I only don't like the ones that are inside, on tab characters also. I don't like tab characters because with tabs, I'm never certain if they're going to show the same way to you or to someone else. Right? Maybe there's hidden spaces in there I don't see, right? So I don't like tabs that way.
It's weird what it did.
What did? Oh, I see. Hang on. You said I see 2 + 3 + 5. Okay. Where's your 2 + 3 = 5? So didn't that work correctly, as you expected?
Well, it's showing.
Well, no, that's
Oh,
the
that's really
previous
funny.
one though, right?
Hey,
Yeah, that's the
Isn't that the one
previous
from
one.
127? Yeah.
oh,
It
what's
shows
going on
nothing.
here? Why is it doing 2 + 3 = 5? Oh, it's doing mine. It's doing mine, not yours. It's my 2 + 3 = 5 up there.
Yeah,
All right.
mine
So
doesn't
where is
work.
yours? Where's yours?
Mine's on here.
There's no C out. All right, get rid of the C out and just say put a string there first. Let's make sure that you're and I also tag it with Alex in within that, right? So in the string you say you say C out Alex's statement, right? And then C out your thing, right? So it's not in comments. So even when we look at the output, we know whose output it is and we can debug it together. Okay, all right. Alex's statement 4 + 3 = +7. All right.
So that
Were you trying to do it
that
without
one
the carrot?
worked.
Were you trying to do it without the carrot or?
All right,
like
so this is a very
concatenation?
interesting problem, right? It's a very interesting problem. Unfortunately, if this was 2B, right? If this was 2B, this would provide for such a juicy 15 to 20 minute talk, right? Why this happens. All right, I'll give you a really small, quick, if you want me to. If you want me to, I will explain why that happens. It doesn't have to make any sense to you, but because it's in a video, you can come back to it, listen to it later on, or discuss it with your friends later. It's not going to matter for your grade, but I think it'll increase your appreciation of C. Yes or no? Do you want to know why that happened?
I would really like for you to
Yeah.
explain it.
Yes? More than one? One, two people?
Yeah.
I would
All
like
right,
it too.
Okay,
I would
great.
like to hear, yeah.
So here's the very interesting that happened. Okay, so Alex's statement that what Alex wanted to print, essentially to see out, was that string. Yes, a string. Alex's statement : 4 + 3 = and so on +7. Yes. Okay. Now here's what happened. Now C out gets past what is called a pointer. We haven't even covered pointers, so don't worry if you don't understand that. Right? Gets given a string. C out is given a string. The operator is given a string and said, here's a string to put into C out, right? Now, however, a string to C++ is represented internally as an address, as a memory address, right? Memory address 45. That is where the string Alex's statement, ALEX. Is everybody okay with that? ASCII characters, ALEX, and so on, have to be stored in memory or not? Yes or no? That thing has to be in memory before C out is told, take whatever is memory and plonk it on the console. Yes or no?
Could you repeat
Someone has
that?
to respond, okay?
Could you repeat that?
Before I tell C out through the operator, right? Before I tell the operator, here is C out, here is a console, here is a string, take the string and put it in the console. Yes? That is what the operator is supposed to do. Yes or no?
Yeah.
Okay, good. All right, now that's a string. That thing that needs to be put on the console is a string. But that string has to be somewhere in memory. Otherwise, how can I tell the operator, here's your string? Yes or no?
Yeah.
Okay, all right. Internally for C++, that string that starts at a memory location is basically just a memory address saying, oh, in byte number 4722, 4722, that's where the string is located. So here is the console, here is byte number 4722, there's a string there. Take the string that starts at 4722 and dump it on the console. That's what
Okay.
we're saying.
So, Professor, when we add 7, are we then not pointing at A? We're
Yes,
pointing at S?
Yes. So exactly. Thank you, Alex. Thank you so much. That is exactly the reason. So when we give it the string, we're giving it the memory address. But however, if we pass that memory address +7, it's giving 7 locations past. So that's memory address +1, the next memory address +2, the memory address after that. So +7 is 7 memory addresses, 7 bytes after A. So it says, here's a console, here is a memory address that contains a string, and that memory address is a string that begins at whatever that address is +7. So ALE, what is it? ALEX apostrophe S C, right? So I think it should basically say, what does it say? Out statement, out statement : 43 equals. I don't know. It says statement : I don't know, you got to work the math out, I think. But basically, that's what's going on, right? So it's going from A. So one ALEX, ALEX apostrophe S. What is it got? Statement. So it's skipping ALEX apostrophe S space. I forgot the space. I forgot the space. All right. So it skipped all those statements, spaces. You need one more for 7. I've only got 6. You guys have to work it out, right? Essentially, it's to skip that many characters and started the string at that point. Does it make sense? I'm actually so glad that Alex brought this up. And we had a chance to dive into a really juicy bit, because what are the chances you would have encountered this, right? And I know even in 2B, right, where it's very rare that you come across a situation and see that not working and say, why is it not working and what's going on? And here's the reason why it's not working, and here's the reason why it's doing what it's supposed to do, right? Figuring that out is a really juicy tidbit. And the landscape is basically strewn with it. There's lots and lots of these little things, right? Which you'll only encounter if you try something and it doesn't work. And then you figure out why it doesn't work. Oh, it actually did this instead of that. But why even if it doesn't work, okay, I agree that it doesn't work, but why did it do this instead of not doing anything at all or doing something wrong? Figuring that, so if you're a person that loves puzzles and wants reasons and tries to figure things out, you have to be bold enough to make mistakes, right? And say, and because I can tell you, right, there's absolutely no fun in getting things right the first time. Right? There's no fun, right? What is the fun? If, I told you, even in an interview, right? If you ask a candidate, here's a problem, solve it, and they just go and write up the solution is perfect, right? It's perfect, bulletproof solution on the screen, on the whiteboard. I am like totally not impressed. And so that's not what people are after, right? Even when you try to program, right? I got to go. Alex has stopped. Yeah. All right. So is everybody okay with this? Right? Can you guys try experiments not working, and then try twiddling with this? Alex has stopped. So is everybody okay with that? Right? So you have to try something and try to do things that won't work. Right? Or try to do things that are not going to work in predictable ways. It'll work, but it'll do something else. And then as a group, you should all try and figure out why it's, and maybe that'll result in more experiments. Hey, this is why it's going on. Let's try this experiment and find out why it's all science, right? It's empirical science. You got to try and do experiments to find anomalies and say, why is this anomaly? How can I explain this? Right? Got to run more experiments to find. So this is basically a taste of computer science, not just homegrown programming. This is how real science starts. So I would really love it if by the end of class, we have 30 comments. 30 comments, everybody in class, right, has their own section, just like that. Anand, Alex, Jared, Hiram, everybody has their own section, which may be something interesting. Doesn't have to be something interesting. If you don't have something interesting to say, just say hello world. That's fine, right? But everybody should have a section, which means that everybody is able to take this program and run it on their own. And then taking this and putting it in IDEs, that's a piece of cake, right? We can talk about that later, or even on Reddit, that's fine, right? Is everybody okay? So I want to hand over, where's Lay gone now? There you go. All right, so Lay, I'm going to make you host and disappear. Is that okay? Everybody okay with that? Right, so you can call out to me, but I'll be back, all right? If not, just end the meeting at 9:50 or whenever the students leave. And we'll pick up next class, or or sooner if you guys email me. All right, but I'll be back soon, hopefully.
Alexandra, could you try?
Okay, this is good.
Hey, I'm back. Wow, look at that. Look at that. Okay, all that exciting code on the screen. That's fantastic.
Thank you.
What's been happening? Is there any interesting stuff? Any juicy stuff that I missed out on?
Wow, that works. Yeah, we've got a lot of weird things.
Wow, the weirder the better. I say, wow, look at that. Look at that. It's only day 1 of programming, really, right? Because last week was all about data representation. This is day 1 of programming, and you guys have already written that much. All right. That is incredible. Incredible. Now, I want to be, so one of the things that happened in previous lectures is that some of the faster students will just keep going. And some of the slower students, or even not even slower students, right? Someone who needed to take a break, right? Maybe a bio break, right? So they went to pee and come back. and then the class progressed so much, and then they can't catch up and they give up at that point, right? So we've had that happen, all these different things, right? You name it. So I want to make sure that everybody's on board, right? Everybody is able to write a program like that, and not this big thing, right? Everybody is able to write a simple program and click run and have it run and produce a result, and maybe tweak things and have it change behavior, right? So I'm going to go one by one, and you should basically say yes or no. Okay, yes, and you can qualify your yes. I did this. That's all cool, right? So, but you should basically give me an answer. All right. So, what about you, Hiram? Did you get a chance?
Yep.
Alexander, obviously, you got a chance. Joshua?
Yes, I did.
Great, great. Maddie? Great. Claire?
Yes.
Excellent, excellent. Lee?
Are we saying yes to we got a chance to
No,
contribute?
you can say anything you want, really, as long as you had a chance to do something here and you're confident that you can write some little program that'll work.
Then yes.
Okay, Francis, what about you? Confident?
Not completely sure.
Oh, okay, that's fine. That's fine.
Yeah.
What we'll do then is, Francis, so next class on Thursday, you should volunteer to drive, right? If you volunteer to drive, what we'll do is that I'll talk you through the code, right? And as you're starting out, you'll see that you're relying more and more on me talking before you type. But towards the end of class, you'll see that you're starting to type even before I call out things, right? So that's a very nice experience to have. So you can volunteer next class first before anyone goes, right? So everybody else will get a chance after Francis' next class. What about Musa? Musa, are you there?
Yeah, I'm here.
Okay, so you just don't like to have your camera on, right?
I don't have one,
You
sorry.
don't have one? Okay, but you got to keep talking. You got to keep talking all the time, right? Just ask questions or you say or things like that. Some feedback. Otherwise, I'm going to assume you're absent. Okay. Yang, what is your name? Yang Yuxin?
Yeah, of course.
Is that your full name or is Yushin your last name?
No, it's my full name.
Yang Yuxin.
Yeah.
All right. So are you confident you can write a program on your own? Just like this?
Yeah.
Right? It doesn't have to be big, but 5 lines. Print something. Yeah? And calculate something and print it. Good, good. All right. Agnes? Yeah? Okay, C++.
Hello.
All right, Maddie, you've got to say yes or no. Madison, not me, Maddie, not Maddie.
Yes.
Maddie, all right, Madison.
Sorry, I thought you were talking to Maddie. Yes.
Yeah, I know. Yeah, if you had, I don't know, was it you in your introduction, in your introductory post, you said you can also call me Maddie?
Yeah, people call me Maddie. We spell it differently, but because there's 2 of us that go by Maddie, I'm fine with Madison.
Oh, I see. That is so interesting. I see. So let's just call you Madison from now on. So Maddie will be the other Maddie.
Yeah, that's fine.
So it's a very interesting bit of trivia is that when I was in undergrad school, not even grad school, undergrad school, my classmates used to call me Maddie, right? Even though my name was totally not Maddie at all, or Madison, or anything to do with math. So because they thought I was a mad scientist, so they used to call me Maddie. Okay. Anyway, so Madison understands. Soe, is it Soe or So?
It's Soe.
Soe? Okay. Well, are you confident you can write your own C++ program today?
I wouldn't say I'm entirely confident, but I'm pretty sure I can
Okay.
get something done.
All right, so you have to get in line behind Francis, okay? So we have Francis and Yunshin, Yang Yushin, and then Soe, right? So 3. You 3 are 1, 2, and 3 for going on, taking the screen. Is that okay with you guys? All right, and then everybody else will also get a chance, right? But we'll start with these 3 first. So that's for Tuesday. What time is it now? Is it now? Yeah, this is funny lecture. Oh, we still got time. We still got 10 more minutes, so we can still play around. The funny thing is, today's lecture is going to come up as 3 parts, maybe. The first part that got cut off when Late hit the screen, and then this part, and I don't know if Late recorded it, so that will be the second part. All right, go ahead. Type more, do more experiments, and if things don't work, and try and find out why they don't work. Have you guys tried expressions, mathematical expressions like floating point expressions, math functions, sine, cos, tan, and so on? You can try all those. So if you want to try a math function, here's one way of doing it, right? So do a cout, and do a comment saying trying out math functions. Trying out math functions. You have to, and then say another comment, another comment there. It says you have to include this line at the very top of the file, right? And say hash include. On the next line, you say hash include. Hash include space, and then within angle brackets, you say math.h, math.h. Right now, at the top of the top, you can get rid of at the top. I don't know if it needs to be at the top, right? No, in the comment, yeah, include it here. Yeah, I don't think it needs to be at the top. You can just put it here too. But the reason we put it at the top is to keep it all organized, right? You can actually put your math.h include file, include statement at the bottom just before you start using math functions. That's fine too, right? How many times have you seen this in Python, right? In Python, sometimes you have, if people use a module and they use it within a block and they just import it within that block alone or things like that. And yeah, it's okay but sometimes you also see programmers that lump all their imports together in one place. So you know, this project uses all these things. So it's up there, right? So that's all. So you have to exercise good judgment and to know where to put what, right? It's the same as globals versus locals, I think. No, maybe that's more complicated, right? You'll find out about global variables and local variables later, and how global variables make it a real pain to debug programs later, right? So we try not to use them. Right, now you can try. So now that you can go back to your code and try math 1045, right? What is 1045? Can someone tell me what 1045 is? Degrees, not radians, right? Pi by 4, pi over 4 radians. What is 1045?
Would it be 1?
Yes, thank you very much. Okay, so no, not Endel. You have to say equals. No, say, oh, put in comments saying 1045 equals and then the value 1045, right? So you know what's being printed. No, on the same line, you can say cout double less than. You can just say 1045 equals right there. And that should be within quotes. 1045 equals should be within quotes. Yeah. And then space, yeah, double equals, and then the actual value, 1045. No, it has to be 1045, 1040. Oh, you do have 10. I can't see it because you know, the window is so small, and then it's in red. I can still see some of it.
Is it in radians or degrees?
Oh, thank you so much. It is radians. The math library uses radians.
Yeah.
Who said that? Who said that, by the way?
I did.
Alexandria. Yeah, all right. So
is there like a
the math
pi?
library uses radians, not degrees. And so what is 45 degrees in radians? It's pi divided by 4, yes? Yeah, pi is 180. Divided by 2 is 90. Yes. Divide by 1 more is pi by 4 is 45 degrees. Yes or no? All right, you guys have to agree with me or not. Yes? 45 degrees.
Yep.
All right, so say math underscore pi. No, unfortunately, you don't have a variable called pi. However, you have a constant called pi. And that constant is called math underscore pi, all in caps, all caps. It has to be all caps. Now it's a, you know, you may think, why is this all in caps? It's a very useful convention that many people don't follow, right? Even modern C++ programs, some people don't follow that. And so anytime I used to hire programmers, I used to say, no, follow this convention, because it's very easy for me to read the code. When people see all caps, they know it's an unmodifiable value, right? So it's a constant, you can't change it, or you shouldn't change it, right? It's a variable that is a constant, right? So so that's why. So when people say all caps, they know you can't change it. So no, it's not MPy. I think it's MPy in JavaScript or Python, or so I think it's math underscore pi. No, it's math underscore pi.
It yelled at me. It wanted MPy.
What did it say? What did it say? Where's the error?
Here, I'll show you.
No, now you won't get the error. We changed it to math. Oh, math pi was not. Oh, I'm so sorry. You're right, Alexandria. It is MPy. Maybe it's math underscore pi in the other languages. All right. Okay. Cool. Yeah. I think in JavaScript it is the pi member of the math object is math.pi or something like that.
Yeah, that's what I remember.
Yeah, math. Yeah, something like that. The crazy thing, is that when you switch from language to language, you tend to forget a lot of the lower level detail. Because of the fact that you can look them up, So that is our unfounded confidence in the internet, right? So we say, oh, I don't need to remember this because I can just look it up, right? So especially if I have a chip that will go in my brain, I can basically trust it 100%, right? No, you can't trust it 100%. You can only trust your own good sense 100%. So, so the chip in your brain will give you access to information faster, but whether that information is correct or not, whether it makes sense or not, is that last mile. That last mile is up to you. And that can never be supplanted by a chip. Because if that is supplanted by a chip, that chip is essentially you, right? And from that point onwards, everything has to, yeah. So I think you have to examine the information no matter where it comes from. And as programmers, what we do is like this, right? So sometime later, you're going to be programming in a different environment, right? Maybe you're going to be cutting Python code and you'll be using C++ syntax. Fortunately, what happens is that most of the time when you switch back and forth between Python and C++, the biggest hurdle that I've seen people encounter is braces and parentheses, right? Because they invert it, so they put parentheses or omit parentheses and the compiler, and it'll take about half hour to 45 minutes before you get into the swing, right? The first half hour, you're going to be inserting parentheses with that. So your speed is going to be not 100 miles per hour. It's going to be like 45 miles per hour, right? Slowly. So that is the biggest hurdle I've seen so far. All right, good. So now if you run this, you should see the values. So do you get 1.0? Oh, you actually do get 1.0. It's not 0.9. I thought you'll get 0.999. Because pi over 4, pi itself is approximate, right? Pi is approximate. And then pi over 4 is even more approximate. Maybe, right? Even more. And then you're taking the tan of that. And the tan, which you will be doing, right? In 2 quests from now, you're going to be writing an implementation of XPax, right? So copy the 2 lines, put them below, and instead of tan, use EXP, which is, EXP, exponent, right?
Oh, I have a question.
Yeah.
Oh, this is long.
Oh, double. Yeah, thank you. And why is it called A10? Oh, you're just naming all your variables.
Oh, because we have way too many variables.
Yeah, no, fine. That's fine. So A10. Yeah, so turn that tan into EXP.
Like this?
Yeah, EXP.
Sorry, I'm missing.
P as in Peter.
Oh.
EXP, and then turn the 45 into 1. Right now, yeah, that's fine. You can make it 1.0 just to be clear that it's a double number and not a. All right, now 1045 equals A10 and 8. Oh, you're calculating A10 there. All right, now here you need EXP 1.0. Yeah, after that, yeah, there where you have your vertical bar. Get to the place. Yeah, there you go. Right, say EXP, and then open parentheses 1.0. Close parentheses. All right. Now, if you run this, EXP, what is EXP? EXP is a function basically that takes the value E. E is the base of the natural logarithm, right? E is 2.71882818, right? That's how much I remember, right? So that is a magic number, 2.71828. It's a beautiful number because it gives you a curve. If you look at a curve of e to the x, it is the slope of the curve. How much the curve bends, right? The slope of the curve is actually equal to the value of the function itself, right? So at any time, if you want to know the slope, how bendy is this curve? You don't need to calculus or anything, right? You just look at the x, y value at that point. That's how much. So I will bend as much as the y. That is essentially what e to the x is saying. So that is why the exponent function is so so key to everything else, right? To logarithms and so e to the x. So now if you say e to the 1, you should get e to the 1 is 2.7182818, right? So you should say if you run that, you should get e to the 1 equals to, yeah, you actually do get it. Yeah, there you go. So that's e to the x. Now if you say log of 2.71828, you should get 1.0. But I bet you will not get 1.0. You'll get something like 2.7. Yeah, do the same thing, copy and paste, but instead of instead of 1.0, because log 1 is 0, right? Any number raised to the power 0 is 1. So log 1 is 0. So you want to say log of 2.71828, not 2.71828. In fact, let's be more accurate, 2.7182818. I think that's how much I remember. 2.7182818. right? Now we should get a value that is very close, and then also that one, yeah, 1.0. Now I think we should get very close to 1. Wow, wow. Okay, I don't know why it's printing 1. It should really, because 2.718, that, yeah, if you use a calculator, and find the log of that, I'm pretty sure you'll get something like 1.0001 or 0.9999, depending on, because that is nowhere near E. E is very different. After 6 decimal point places, E is different from what I put it there. So, and the fact that it says that log of that is 1 is, maybe it's just treating it as an integer and rounding it off. Maybe it'll help to do what you did before, right? Where you said, you know, double A, yeah, like that. Yeah, I think that might actually help. Yeah, say 11. Yeah, I hope this will get as a number. Wow. Try 2.718, right? Just try 2.718. Yeah, run it. Okay, all right. So it's converging too fast. So yeah, maybe a good thing. So anyway, you get the idea, right? You get the idea. So you can play around with this, and you look. I mean, we tried something, it didn't work, or at least didn't work the way that I thought it should work, and we tried different variations of it. Now, what I would like is, what time is it now? I've got about 3 minutes, but today after class, okay, after class. Now you guys have to be like super duper important. So here's the thing, right? In my CS2B section, I'm seeing a huge shakeout. A large number of students are basically dropping because they can't handle it. And I don't know, I haven't seen this before, right? This is the first time this is happening. And my suspicion, my hypothesis at this point, which we're gonna try and find out, right? Because we want to do a program review and find out why the hell this is happening. Why are my 2B students? I think it's because, and I look at it and I see that a lot of 2B students just came in without basic mechanics knowledge. Mechanics meaning C++ mechanics, how to use a for loop, how to use these. Some of these things we're doing now need to be totally grounded, right? You need to know about pointers and all these, which you will. If you stick with me through the end of this course, you will like today, everybody will, at the end of this course, will be in a position where you can write a program like this, which is enough for 2B. But I have a lot of students who can't do that. And I think what happened is, because of the pandemic and everything, I think compassion and pity and all these things are people probably did things the wrong way and said, you know, I feel sorry for you, so I'm going to make you pass, even though you did a sloppy job. And I think maybe a lot of that happened. And a lot of people just passed 2A with flying colors, even though they didn't do a good job because they were impacted by other factors. No, if you're impacted by other factors, that's fine. I will help you overcome life situations, but I can't give you a pass in 2A. Maybe I'll help you find food, right? So you survive, so that when you're able to think clearly, you can come back. Then you can do 2A, and then I'll be able to give you a pass when you deserve it, right? And so I think so my hypothesis is that a lot of people got given undeserved A's and undeserved passes before when they didn't have basic knowledge, and that is impacting teachers now who have to teach advanced courses, because they have a lot of students who don't have basic knowledge. And already in computer science, that's a big problem in the Bay Area, right? Because as I said before, right, Python and JavaScript, lots of languages, let people do simple things very easily. And every time some major breakthrough happens in knowledge, right? Computer science, math, whatever it is, it'll be in the realm of experts initially, but eventually it has to filter down to the masses, right? So math now, arithmetic, algorithms for arithmetic, right? Carry and borrow, that used to be done by advanced people before, but now we teach that in kindergarten. So by the time the students come to like 5th grade, they know how to do addition, but they don't have to be experts. But doesn't say, yeah, I know how to do these complex algorithms for addition of numbers, therefore I'm a mathematician, right? No, people don't do that, right? Because it's the art has had a long time to mature. So that should happen to computer science also, right? So all these things that people do in computer science, now they're becoming so simple that they can be taught in elementary school. People can write simple programs, right? But that doesn't make one a programmer. That makes someone know how to use computers, but not a programmer. So CS2A, BC, you should approach that with the idea of learning to program, which is real computer science, right? What is the impact of doing this versus that? I can do it in a million different ways, but which is the best way to do it? That's the way we're asking, right? That's our question in CS2A, BC, right? Whereas before that, we're saying, I need to do this. Can I do that at all? Or how do I do it? Right? No, how do I do it is a human question, right? How best do I do it? That is the engineer's question. So that's what we should be trying to do. And so keep this. So hey, Alexandria, this is online GDB, right? So it should have a share link somewhere, right? I'll leave you to find out. You don't have to find out now. It should have a share link, which will allow anyone to access this code without having to log in, right? And that's one of the reasons why I tried to discourage people from using that other site last quarter, because people can, it'll share code and edit the program, but then you have to log in to that site, right? But GDB allows you to share a link that doesn't require login. They can go and view the code. If you can find it and post it in Reddit and share it with your students, everybody can go and change this code, right? And if you have any questions, feel free to ask, right? Feel free to ask in the Reddit and by the way, starting today, points will start expiring. So make it a point, go and just contribute, right? Talk to each other in the forum, ask intelligent or stupid questions, that's fine, right? If it's totally stupid, I'll come and delete it, right? So, or one of your classmates will point out, right? Look out for each other and then we'll delete it, so that what we want to do is help each other maintain really solid profiles, so that when you go to an employer, they can basically just look at your Reddit profile and say, hey, I want that person, right? So help each other maintain these solid profiles, report, posts that you may want that person to have deleted, right, to me, so that I can check with that person. And so keep it solid, right? And make it a solid reference site for future students also, and share this code. This is really cool, right? And have intelligent, interesting discussions all the time. And yank me in, right? Yank me in when you have, time, or need me to be part of a discussion. That's fine. I'm happy to be in it, right? Either on Reddit, or if you want a special Zoom session, that's fine too, right? We're trying to find a time that works. So was this class helpful to all of you? Did all of you, are all of you reasonably comfortable with writing a very simple C+ program? Yeah? Okay, good. So this is where we start. That's fine. Francis and the two other people, right? I think Musa also, right? And Yan Yoshin. Right? So these three, maybe next 2 or 3 classes, we'll get a chance to code. Next class, we'll do something more, right? We'll try and accept user input. We'll try accept user input and so on, right? And react to user input. So we'll have some interactive program. So we'll try and take this and slowly make it more and more exciting, right? So eventually what we want to do is, by the time we come to lecture, I don't know, week 6 or week 7, we want to be in a position where we can turn this into some kind of a game that's interesting enough to play for us, right? So during class, we can actually play a game that we created, right? How cool is that? And then for those of you who are interested, I think I tried this a couple of times before. Those of you who are interested, if we do something really cool in class, I can actually show you how to turn that into a web app, right? On the web, without having to own a server, a machine that you need to babysit every day. I can show you how to turn that into a web app, so that people can just go online to, something like clairerand.com, right? And play a game. So, fancy graphics, and I can show you all that. It's all very simple. A couple of Zoom sessions on Saturday, you can crack that out, right? So thank you so much. Thank you for coming. I hope this class was useful, and you are coming on, today's Tuesday. You guys are coming back on Thursday, yes? All right, please maintain the healthy attendance like this, and let's try and start sooner and sooner, okay? Let's not wait until 8:10 from now on. Because we're going to start coding, and you guys are going to start coding increasingly. We should not wait until 8:10 to start coding. So let's try and start at 8:05 next class, okay? Which means we'll start sooner, and then if that works, we'll try and push sooner and sooner, so that eventually maybe we'll just start at 8 o'clock, and you guys can start coding, bam, on the bell like that. Okay, so that'll be fun.
Thank you.
And thank you all so much for coming. And it's all well past the end of class time, and you're still sticking around. So I greatly appreciate that. I will see you guys on Thursday, okay? And be early and have a good time. And keep coding, keep coding. It'll be fun. It'll get fun if it's not fun yet. All right, bye.
Thank you.
Bye.